Good morning, students. Today in this session we are going to solve our exercise 1.5. Before that, let us see some examples related to exercise 1.5, and the topic is rationalizing the denominator. As I have told you earlier, rationalizing the denominator means to make the denominator a rational number. For example, in a given number, if the denominator is irrational, you have to make the denominator rational by applying some steps. And what are those steps? Let us see with an example. So the first one is 1 by root 2. You have to rationalize the denominator. Here the denominator is root 2. That is an irrational number. Why root 2 is an irrational number? Because its decimal expansion is non-terminating. So root 2 is irrational, we have to make it rational. We want to write 1 by root 2 as an equivalent expression. We have to write an equivalent expression of 1 by root 2 in such a way that its denominator is a rational number. Equivalent means nearly equal. So we will make this an expression which is nearly equal to 1 by root 2, but in that expression the denominator is a rational number. So if you are, I have told you earlier, if you are given any value under the root and if you want to skip this root value, so you have to make it square, because here the root power is 1 by 2, and if you make the square of this, 2 and 2 will cancel each other and your answer will be a complete number. So if we want to make root 2 rational, we have to multiply it by root 2. Then the power will become square. So root 2 multiply root 2. When two roots are together, they will cancel each other. Or we can say that here the power is 1 and half, and again the power is 1 and half. Half plus half equal to 1. So we can say that when two roots are multiplied with same base, we can say that the answer is our base value. So to make the denominator rational, we have to multiply the denominator by root 2, and if you are multiplying the denominator, you have to multiply the numerator also. So what will we do? We will multiply and divide 1 by root 2 by root 2. That means 1 by root 2, multiply the numerator and multiply the denominator. 1 and root 2, root 2, and root 2 and root 2 will become 2. So here the denominator will become rational. This is known as rationalizing the denominator. This is your first example. Now let us go for the second one. That is 1 is to 2 plus 3. 1 is to 2 plus 3. To make the denominator rational, we have to use some identities. I have told you about some identities in the last topic. Here we have to use that identities, and the identity is a plus root b, a minus root b. We have studied one identity, a plus b, a minus b is equal to a square minus b square. Here we have modified this one in this way, a plus root b, a minus root b, it will become a square minus root b square, and whenever we will take the square of a root value, the root will cancel the square and the answer is that number. So the same will come here, a square minus b. The value of a is 2 and the value of b is 3, so we will put it like this, and we will get 2 square minus root 3 square. 2 square is 4, root 3 square is 3, 4 minus 3, 1. So if you will multiply the denominator by 2 minus root 3, you will get the value as rational. So what you have to do? You have to multiply the numerator and the denominator by 2 minus root 3. Just you have to change the sign. Here the plus sign is given, you have to change it to minus. So 2 plus root 3, we will multiply by 2 minus root 3, 2 minus root 3. 1 multiply 2 minus root 3 is equal to 2 minus root 3, and in the denominator it will become 1. So the answer is 2 minus root 3 and the denominator will become rational. The third example is 5 divided by root 3 minus root 5. So to make the denominator rational, we have to use the identity root a plus root b, root a minus root b is equal to root a square minus root b square. Same identity, a plus b, a minus b is equal to a square minus b square. So root a square will become a, root b square will become b. So we will put the value of a is equal to 3 and b is equal to 5. Root 3 minus root 5, root 3 plus root 5. It will become root 3 square minus root 5 square, 3 minus 5 minus 2. So to make the denominator rational, we have to change the sign of this one and multiply the numerator and denominator by that. So root 3 minus root 5 we have, so we will make it minus plus. So we will multiply and divide the numerator. We have multiplied the numerator and denominator by root 3 plus root 5, root 3 plus root 5. So here it will become 5 into root 3 plus root 5, and in the denominator it will become minus root 2. Clear? Now the last example is 1 by 7 plus 3 root 2. Again the same thing is there. You just have to change the sign of the value given in the denominator. Here it is given 7 plus 3 root 2. You have to multiply it by 7 minus 3 root 2, 7 minus 3 root 2, and the identity I have written here, a plus root b, a minus root b. So after putting the values, we will find the answer. Here 3 root 2 square value. One value is given, 3 root 2 whole square. Here it is. So how will we solve this? It is square of 3 and square of root 2. Because whenever it is written am whole square, that means it is the square of a and it is the square of m. So the same thing is here. Here the square of 3 and square of root 2. Square of 3 is 9. Square of root 2 is 2. So 9 2s are 18. So the answer of 3 root 2 square is equal to 18. Clear? Now let us go for our exercise. The first question is, classify the following numbers as rational or irrational. You are given a number and you have to tell that this number is rational or irrational. So three things you have to keep in your mind. Whenever you will operate a rational with a rational, whenever you will operate a rational with a rational, the answer is always rational. Whenever you will operate a rational with irrational, the answer is always irrational. Rational plus rational, rational. Rational plus irrational, irrational. But whenever you operate irrational with irrational, we can't predict without knowing the answer that the answer is rational or irrational. Clear? Now the first question is 2 minus root 5. Here 2 is a rational and root 5 is a irrational number. So this is rational with irrational. So whenever rational with irrational is there, the answer is always irrational. Next is 3 plus root 23 and minus root 23. So as we know, 3 plus root 23 is irrational and minus root 23 is also irrational. So irrational plus irrational, we can't predict without knowing the answer that it is rational or irrational. So we will solve this. 3 plus root 23 minus root 23. So root 23 cancel. We will come with 3. And 3 is a rational number. So this is rational. Next one, 2 root 7, 7 root 7. Here both are irrational. This is irrational, this is irrational, because root 7 is irrational. So root 7 cancel, root 7. So we will left with 2 by 7, and 2 by 7 is a rational number. 1 by root 2. Next question is 1 by root 2. As we know, root 2 is irrational, 1 is rational. So rational plus irrational is equal to irrational. So 1 by root 2 is irrational. Last one, 2 pi. As we know, pi is irrational and 2 is rational. So rational plus irrational is equal to irrational. So 2 pi is also irrational. Second question, you have to simplify the given expression using the identities. So the first one is 3 plus root 3, 2 plus root 2. This is a plus b, C plus D. So we will use the formula root A plus root B, root C plus root D. Distributive law we will apply. First one is multiplied by both and the second one is multiplied by both. First we will multiply root A with C and D, and then we will multiply root B with root C and D. So we will solve it like this: root AC, root AD, root BC, root BD. That is when root A, root C, root B, root D are given. Now in our question, what is given? 3 plus root 3, 2 plus root 2. So first of all we will multiply 3 with 2. 3 2s are 6. Then we will multiply 3 with root 2. That will come out to be 3 root 2. Then we will multiply root 3 with 2. That will become 2 root 3. And then we will multiply root 3 and root 2. That will become root 6. Because whenever two numbers are multiplied and root power is there, they will, whenever you are given like this, root P multiply root Q, we can write it as P multiply Q. Clear? Second one, 3 plus root 3, 3 minus root 3, that is A plus B, A minus B. So it will become A square minus B square, and here root 3 is given, so it will become B, A square minus B. So we will put the values and we will get the answer is equal to 6. Next is root 5 plus root 2 square. So this is A plus B whole square. So root A plus root B whole square, root A square plus 2 into root A into root B plus root B square. So whenever square of root is given, that will become a complete number. So root A square will become A and root B square will become B. So after putting the values of A and B, we will get the answer 7 plus 2 root 10. Next one, root 5 minus root 2, root 5 plus root 2. A plus B, A minus B, it will become A square minus B square, or here root is given, so it will become A minus B. So you will check it from here that how I have solved this. Third question, recall pi is defined as the ratio of circumference of a circle means the boundary length of the circle to the diameter. How we have recalled this? Because we have studied 2 pi r, circumference is equal to 2 pi r, and we know 2r is equal to d. So we can write circumference is equal to pi d, or we can write pi is equal to c by d. This is what is given in the question, c by d. So this seems to contradict the fact that pi is irrational, because we have said that pi is irrational, but here we have written it into the form of a rational number. So how will you resolve the contradiction? How will you say that pi is irrational? Because we have expressed it here in the form of a rational number. So the answer is, whenever you will measure any value with the help of scale or any medium, that is just an approximate value, not exact value, because there are so many numbers between two numbers on the scale. So many numbers are there, real numbers, between any two numbers on the scale. So we can't say that we have exactly measured the value. So if you don't know the exact value, you can't say that it is rational. So that's why we have said that pi is just an approximate value, so it is irrational. Clear? Now the fourth question, you have to represent root 9.3 on the number line. So what you have to do, the first step, you have to draw a straight line. AB is equal to 9.3 units. Then what you have to do, you have to draw BC is equal to 1 unit. First of all, you have to draw AB is equal to 9.3 units. Then you have to draw BC is equal to 1 unit. Then what you have to do, you have to find the midpoint of AC. As we have said, AC is equal to 9.3 plus 1. AC is equal to 9.3 plus 1, 10.3. So we will find the midpoint of AC, that is equal to 5.15. So we have marked O So we will mark O at 5.15. Now taking the radius equal to OC, placing your compass at point O, you will make a semicircle of radius 5.15. Placing the pointer of the compass at point O, you will make a semicircle of radius 5.15. Now the next step, what you have to do, you have to draw a straight line, and that line must cut the semicircle at point D. Now this BD is root 9.3. Now the next step is, you have to measure this BD value with the help of your compass. You have to place the pointer at point B, and you have to place the pencil side at point D. So you will measure this value with the help of your compass. You will place the compass at point B, and then you will make an arc like this, and this point E where it cuts the line AC is your root 9.3. So what you have to do, first of all you will draw a line. AB is equal to 9.3, then you will increase it by 1 unit. So BC is equal to 1 unit. Now AC will become 10.3 units. You will find the midpoint of AC and mark it as point O. Now you will make a semicircle with radius OC. Then you will draw a straight line perpendicular, that is BD. Now measure the length of BD with the help of your compass and make the equal radius arc which cut the line at point E. This point E is your value of root 9.3 on the number line. Clear? Now next question is, rationalize the denominator. So the first one is 1 by root 7. Similar to 1 by root 2, we will multiply it by root 7 and root 7. So root 7 will become 7. So the answer is root 7 by 7. Next is 1 by root 7 minus root 6. So we will use the identity root a plus root b, root a minus root b. It will become a minus b. So we will put the values and we will get the denominator equal to 1, that is a rational number. So just have to change the sign. See, you can see here I have just changed the signs whatever is given here, and after that I will get the denominator as a rational number. So you just only have to change the sign and then you have to multiply using the identity. Same in the next question, root 5 plus root 2. I have just changed the sign here, root 5 minus root 2. First of all you will study the complete question. I am just giving you an idea that what number you have to take. So root 5 plus root 2, here I have taken root 5 minus root 2. So after using the identity we will get the denominator equal to 3, that is a rational number. Now the last question is root 7 minus 2. So what you have to do, root 7 plus 2 you have to take, and then you have to multiply using the identity and you will get the denominator as a rational number. That's all in your exercise 1.5. I hope you all understand. Thank you and have a nice day.